Okay, from tableau 9, from tableau 9, we got the new type of calculations, LODs. Okay, the new type of calculations are known as the LOD. So what is an LOD? LOD stands for level of detail. Level of detail. So these are the most important calculations, and these LOD calculations helps us to do the calculation at the required dimensionality level. Okay, at the required dimensionality level, we can able to aggregate the data and we can able to do the required calculations. So this LOD is the next scenario. Okay, scenario number 17. So my agenda for this session is like I'm discuss what does LOD mean and how we can write the LODs, how do they work, I'll discuss some tasks and also discuss the limitations of the LODs. So first let's start with the first basic question, LOD. So what is the meaning of LOD? So by default in Tableau, if you take any view, if you take any visualization, that view will have some level of detail. If you take any visualization, that view should have some level of detail. So let me open Tableau. Just open Tableau. So it will open. Meanwhile, let me discuss about syntax of LODs. So the syntax is common for all the LODs. If you are writing any LODs, all the LODs should be between the curly brackets. All the LODs should be between the curly brackets. So this LODs contains three parts. This LODs contains three parts. Part 1, okay, part 2. LODs contains three parts. Part 1, part 2, colon, part 3. Colon, part 3. Okay, always the LODs contains three parts. Okay, part 1, part 2, colon, part 3. So what is part 1? Part 1 is the LOD keyword. Part 1 is the keyword in the LOD. And part 2 is the dimensionality. Part 2 is the dimensionality. And part 3 is the aggregation. And part 3 is the aggregation. Okay, LOD contains total three parts. Part 1, part 2 and part 3. So part 1 is the keyword. So part 2 is the dimensionality and part 3 is the aggregation. So in LOD, in LODs, in the level of detail expression, we have three keywords. Number 1, fixed. Number 1, fixed. Number 2, include. Number 2, include. And number 3, exclude. Number 3, exclude. Okay. The keyword in the LOD is having, okay, the part 1 in the LOD is having three keywords. The three keywords are fixed, include and exclude. Next, number 2, dimensionality. As the LOD going to aggregate the data at the required dimensionality, we have to specify that dimensionality in the part 2. And part 3 is the required aggregation. And part 3 is the required aggregation. So the output of the LOD is part 3. Okay, LOD going to give us the output in the form of part 3. Okay, so it is the basic syntax of the LOD. So before going to the LODs, let me Let me connect to one data source and let me explain what exactly the level of detail means. So let me connect to the superstore. Here I'm taking, let's say, profit. If I drag the profit and if I drop it into text, here Tableau is showing us the profit, right? Here Tableau is showing us, okay, one profit aggregated value. So here what is the total aggregated value? 6.717 million. Okay, 6.717 million. So this profit is at which level, guys? Here Tableau is showing us this profit at which level? So we are having this profit at the level of the superstore. We are having this profit at the level of the superstore. So at the superstore level, we are having this profit. So it is at the data source level. Now if I drag the continent and if I drop it into rows, now Tableau going to show us the profit at the level of the continent. Now the Tableau going to show us the profit at the level of the continent. It means here we are seeing the continent wise profits, right? So now here we are having the profit at the level of the continent. So it means we can able to add the required level of detail at the view level. So if I take one more dimension, if I take here one more dimension, now here we are seeing the profit at the level of continent plus customer segment. Here we are seeing the profit at the level of continent plus customer segment. So at the view level, if you take the multiple dimensions, those multiple dimensions will add the level of detail. Okay, those multiple dimensions will add the level of detail. So apart from these levels, if you want to add any other level of detail, apart from these levels, if you want to add any other level of detail and if you want to perform the evaluations, then we have to use the LOD expressions. So LODs are going to perform the aggregations at the required dimensionality level. So if we take only the sum of sales, the sum of sales is at the level of the data source. And if we take the segment, here we are seeing the sum of sales at the level of the segment. And if we take segment and category, we are seeing the sales at the level of both the segment and the category. So by default, we can able to see the level only at the view level. Okay, only at the view level. So it means each and every visualization of Tableau is having some level of detail. So if you place the fields into the rows and columns, they are adding the level of detail, right? So which fields? Only dimensions. Okay, one important point is only dimensions will add the level of detail. So if we place any dimension into the rows or columns, it is adding the level of detail. So to any other shelf will add the level of detail or not. Yes, even the other shelves also will add the level of detail. For example, I am building one scatter plot. I am taking sales and I am taking profit. Okay, I'm taking sales and I'm taking profit. And I'm dragging the customer name and I'm dropping into detail. So if I drag the sales and if I drop into the profit, here how many scatters here Tableau is showing? Here Tableau is showing only one scatter. It means the scatter belongs to the complete data source. Now if I drag the continent and if I drop it into color, Tableau going to divide that scatter into 6 parts. Here we are seeing 6 scatters. Here Tableau has divided that scatter into 6 parts. It means Tableau is showing us the sales and profit relationship in the form of scatter plot at the level of continent. Okay, at the level of continent. So it means the color also will add what? The color also will add the level of detail. And if you drag the customer segment and if you drop it into label, if you drag the customer segment and if you drop it into label, let me drop it into label. Just a minute. Let me drag the customer segment and let me drop it into label. See here now after dragging the customer segment and dropping into label, so here it is showing how many marks? 24 marks. So when I have placed it continent, just I had only 6 marks, and after placing the customer segment, it is showing 24. It means we have 4 customer segments, so 6 into 4, 24 customer segment here Tableau is shown, right? So in Tableau, which fields will add the level of detail means in Tableau, which fields will add the level of details to the visualization means the columns will add the level of detail. So if I place any dimension into the columns, it is going to add the level of detail. And if I place any dimension into the rows, it is going to add the level of detail. Not only this rows and columns, if I place any dimension into the color, size, label, detail and path, they are going to add the level of detail. So which shelves will add the level of detail to the visualization means if we place our dimension into any of these shelves. Okay, if I place any dimension into any of these shelves, they're going to add the level of detail. So which fields they won't add the level of detail? Okay, filters and the tooltip. Filters and the tooltip, they won't add any level of detail. Even though if you place any field into the filter shelf or into the tooltip, they will not add any level of detail. For example, I am placing here one field. Just here I am taking here a new sheet. I am taking here sales into profit into columns and the sales into rows. Okay, here I am having one scatter. I am placing continent and I am dropping into tooltip. If you place the content and if I drop into tooltip, here still we are seeing how many scatters, only one scatter. I am dragging customer segment and I am dropping into filter. So if I select any customer segment, just click on apply, click on OK. So here still we are seeing only one scatter. So which shelves they won't add any level of detail means the filter shelf it won't add any level of detail, and even the tooltip also it won't add any level of detail. Okay, these two things they won't add any level of detail. So which fields will add the level of detail means okay the filter shelf, sorry not filter shelf, the row shelf, column shelf, pages, color, size, label and tooltip, okay path and even the active area. These shelves they're going to add the level of detail to the visualizations in Tableau. So if you take sum of sales, as you have seen already, it is going to calculate at the visualization level of detail. So to the sum of sales, if I add something like okay, fixed store sum of sales. So as I have told, LOD contains three parts. LOD syntax contains three parts, right? So what are the three parts? The three parts are part 1, part 2 and part 3. So part 1 is the keyword. Okay, part 1 is the keyword. Okay, part 1 is the keyword. We're having three keywords. The three keywords are fixed. The three keywords are fixed, include and exclude. Okay, the three keywords are fixed, include and exclude. Just a minute. As the LOD syntax contains three parts, the three parts are okay, part 1, part 2 and part 3. So the part 1 contains three keywords. The three keywords are okay, fixed, include and exclude, and the part 2 contains the required dimensionality and the part 3 contains the aggregation. So if you see here, okay, so if you see here it is, yeah. If you see a fixed store sum of sales, then fixed is one keyword. So store is the dimensionality and sum of sales is the aggregation. So it is going to calculate sum of sales, okay, at every store level. So before calculating this, we should know about these keywords: fixed, include, and exclude. So as I have told, the LOD contains the three keywords: fixed, include, and exclude. Next, the dimensionality. In the dimensionality, you have to take the required dimensionality field, and we have to take your column. Here, you have to take the column, and next, you have to take the required aggregation. Okay, next, you have to take the required aggregation. So in the aggregation here, you have to take either field, okay, either field, or even we can take the some formula, like we can take two fields and we can use some formula, or even we can take some logical evaluation also like this. Even we can take here some logical evaluation also like this. Okay. So finally we have to end or finally we have to place the complete logic within the curly brackets. It is the LOD syntax. Okay, it is the LOD syntax. So first let's start with the fixed. What fixed will do? We take fixed, what fixed will do? So Always the visualization will contain what, some level of detail, right? Always the visualization will contain some LOD, level of detail. And from 9 we can able to take the LOD at the expression level or LOD at the calculation level. Okay, LOD at the expression level or LOD at the calculation level. So what fixed will do means, fixed going to perform the aggregation, fixed going to perform the aggregation only at the level of expression. Fixed, it performs the aggregation, only at the level of expression by ignoring the dimensions at the visualization level. So what fixed will do means, fixed it is going to perform the aggregation only at the level of the expression. Okay, it means if you take some expression or if you take some calculation or if you take some formula, only it will perform the aggregation at the formula level by ignoring the dimensions at the visualization level. So the name itself is telling fixed. It is going to fix at the expression level by ignoring the visualizations. So let's say for example, here the visualization is having two dimensions. Okay, here the visualization is having two dimensions. It means the this LOD here, the visualization level of detail is state and counting. Okay, at my visualization level, I'm having two dimensions in my rows or columns, state and counting. In the expression level, in the LOD expression level, I'm taking here customer ID. So customer ID is the dimensionality I'm taking at the LOD level. So fixed is the keyword. And if I take sum of sales aggregation, so what is sum of sales? Part 3, right? So part 3 is the output for the LOD. Part 3 is the output for the LOD. So now here, at which level Tableau going to calculate the sum of sales? At which level Tableau going to calculate the sum of sales? So Tableau going to calculate the sum of sales. Tableau going to calculate the sum of sales at the level of customer ID. At the level of customer ID. So just a minute. Okay, here Tableau going to calculate at the level of the customer ID. Yes, okay, because as it is being the fixed, it is going to calculate at the level of the customer ID because it will ignore the dimensions. It will ignore the dimensions at the visualization level. So fixed only compute at the dimensionality of the expression. It is going to compute only at this expression level by ignoring the dimensions at the view level. It won't consider this. Okay, it won't consider this. Okay. So once here is all of you. I'm taking to demonstrate fixed. I'm taking one example. So I'm creating a new sheet. In my view, I'm taking continent. In my view, I'm taking continent, and I'm taking customer segment. I'm taking customer segment, and I'm taking sales. Here, what I'm doing is I'm creating one LOD using fixed. So I'm taking fixed. So always the LOD should start with what? Curly brackets. I'm taking curly brackets and I'm adding the curly brackets. Right? So now I'm taking the part 1. What is part 1? Part 1 is fixed. And what is part 2? Part 2 is the dimensional. So at which level here I would like to perform the aggregation at the continent level. At the continent level I would like to see the sales. I'm taking fixed continent column. We have to separate with the column. Sum of sales. So in my view I'm having, in my visualization I'm having content and the customer segment. In my visualization I'm having the content and the customer segment. In the LOD I'm taking continent. In the LOD I'm taking fixed continent. Just click on apply and click on OK. Okay. So now once drag the fixed, Once drag the fixed and drop it into the visualization. Once drag the fixed and drop it into the visualization. So now we see the fixed here. For Africa it is showing only one value. For Asia it is showing here only one value. For Australia it is showing here only one value. For Europe it is showing here only 100 means. So what this value indicates? It is fixing the sum of sales at which level? It is fixing the sum of sales at the level of continent, right? So at the continent level it is finding what? At the continent level it is finding the total sales. So once see the total sales for the continent, drag continent, drag sales. So at the Africa the total sale is 2.07 million, at Asia 11.3 million. So here we are seeing only that panel is Australia, okay, 415,000, Europe 2.6 million. So here we are seeing the values at the level of the continent. So fixed is fixing, here fixed is fixing at the dimensionality of the expression. Next, we have the second type of LOD called as include. What include will do? Include, it is going to include the dimensionalities at the visualization level. Include going to include the dimensionalities at the visualization level plus dimensionality at the LOD level. It is going to include the dimensionalities at the visualization level plus dimensionalities at the LOD level. So it is going to compute the sum of sales. It is going to compute the sum of sales for every state, county plus customer ID. Okay, it is going to compute the sum of sales at the level of state, county, okay, plus customer ID. So the dimensions at the vis level plus the dimensions at the LOD level. Let me take one example. I am taking category, or let's say I am taking department. Okay, I am taking department and I am taking category. I am taking category and I am taking sales. So here what we are seeing here we are seeing the department wise, category wise total sales, right? Here we are seeing the department wise, category wise total sales. So in this department, which category is having the highest sales? Sales and chairman. In this department, which category is having the highest sales? With storage and organization. And in the technology department, which category is having the highest sales? Office machines. Now in my next sheet here, what I would like to do is, for every department, the requirement is to show which category is having the highest sales. For every department, the requirement is to show which category is having the maximum total sales or highest total sales. So for that, just create a calculated field, the name max total sales, okay, and here just define the logic, just take here include, okay, include. In include, I am taking the required dimensionality. So what is the dimensionality? Category, because we are doing the category level, right? So include category, sum of sales. Include category, sum of sales. It is the expression I am taking. So it is going to include what? It is going to include the category with the department. So what include going to do is going to include the dimension in the LOD expression with the dimension in the visualization. So it is going to give us department wise, category wise sum of sales. So here one important note point is, here in the LOD, what is the output? Aggregation, right? So by default in Tableau, we cannot take one aggregation over the other aggregation. In Tableau, we cannot take one aggregation over the other aggregation, right? So here, Already in the LOD we are taking the aggregation. So now here as here we want to find out the maximum total sales. Here again we need to take out max. So on the LOD output, is it possible to take the aggregation or not? Yes. So one most advantageous factor of, or one most advantageous feature of LODs is you can able to aggregate the aggregates. We can able to aggregate the aggregate fields directly. We can able to aggregate the aggregate fields directly. So what does it mean? Here, as I would like to find out the maximum of the sum of sales, I'm taking here simply max of. I'm taking here simply max of. So now this now this internal expression going to gives us department wise, category wise sum of sales. On that, just we're finding the max. So just see if the calculation is valid. Click on apply and click on OK. So once drag this max total sales, drag it and drop it into text. So now here we see, now in the max total sales tab is showing us some values. So what does this value indicates? So we go to sheet. So in the furniture department, which category is having the maximum total sales? As here we are seeing the sum of sales. Okay, because the internal expression is giving us what? This internal expression is giving us department wise, category wise total sales. On the department wise, category wise total sales, here we are finding out max. Here we are finding out the max. So in this department, okay, this category is having the highest sales, and in this department, this category is having the highest sales, and in this department, okay, this category is having the highest sales. So we go to the sheet. Here we can able to find department wise maximum total sales of the maximum total sales of the category. So in this way, we can able to go to into much deeper of the dimensions, and we can able to perform the analysis using the LODs. So any questions on this, guys? Any question on this task? Okay, alright. So I'm continuing. So include is including what? Include is including the dimensions in the LOD expression plus the dimensions in the visualization, right? And we have one more keyword called as exclude. We have one more keyword called as exclude. So what exclude will do? Exclude will work in the opposite way of include. Exclude will work in the opposite way of include. So in my visualization here I'm having state county. In my LOD expression I'm having county. So it is going to take the dimensionality in the visualization. So state, it is going to take county, okay, and it is going to take minus of county because the visualizations in the dimensionality minus the visualizations in the LOD expression. So it is going to give us sum of sales at which level? It is going to give us the sum of sales at the level of state. It is going to give us the sum of sales at the level of the state. So next even the in the LOD the dimensionality is not mandatory. Okay, the part 2. So what is the LOD syntax? Part 1, part 2 and part 3, right? So what is part 2? The part 2 is the dimensionality. So part 2 is not mandatory. Okay, so if we don't take mandatory, if you don't take the dimensionality in the LOD expression, so then how the LOD expression going to work? So here in my visualization I'm having two fields, state and county, and in the LOD just I'm taking include sum of sales. So here I'm not having any dimensionality. So what include going to do? Include going to include the dimensions in the visualization plus dimensions in the LOD expression, right? So it is going to include those two dimensions, state and county, plus here 0. So it is going to compute sum of sales, okay, for each state and county. Similarly, in the exclude also, if we omit the dimensionality, it is going to compute for both the dimensions in the visualization. So one important certification question is when the include and exclude will work in a similar way. Okay, when the include and exclude will work in the similar way. If our visual, in the LOD expression if we don't take any dimensionality, then both the include and exclude will work in a similar way. So just go to Tableau. I'm taking here continent. I'm taking customer segment. So in the LOD expression, if we don't take any dimensionality, both the include and exclude they are going to work in a similar ways. So I'm taking include. I'm not taking any dimensionality. I'm taking colon sum of cells. Colon sum of cells I'm taking. Okay, so just click on apply and click on OK. Once drag the include one, drag it and drop it into text. So it is computing at which level? At the level of continent plus customer segment. I'm taking exclude one. In exclude one, again I'm taking exclude. I'm not taking any dimension. I'm taking it sum of. I'm taking a sum of cells. Okay, I'm taking a sum of cells. Just click on apply and click on OK. Once drag the exclude and drop it into the visualization. See, both include and exclude are giving us what the same output. So when the include and exclude will work in the similar way, means if we don't take any dimensionality in the LOD expression. And even for the fixed also, we can take it. Okay, even for the fixed also we can take the expression like this. So what fixed going to do? The fixed going to perform the aggregation only at the dimensionality of the LOD expression, right? So if I don't take here any dimensionality, in the LOD expression, then it is going to compute the sum of cells at the level of the complete data source or at the level of the complete table. Okay, it is going to compute the sum of cells at the level of the complete table. So for example, fixed one I'm taking. So here I'm taking fixed sum of cells. I'm taking here fixed sum of cells. Okay, just now here Tableau going to compute the sum of cells at which level? At the dimensionality of the fixed. But here I haven't taken any dimensionality, right? So it is going to compute sum of cells at the complete table level. So just click on apply and click on OK. Now drag the fixed one and drop it into the visualization. So now it is giving us what? 30.43 million. It means it is giving us the total summation of the sales. So once if you add the grand total, how to add grand totals? Click on analysis, totals, column grand totals. If you add the grand total, what is the grand total value? Okay, the grand total value is 30.4 million. So here how much value we got? Here we got 30.4 million, right? So fixed going to compute at which level? At the complete table level if we don't take any dimension. And even if you don't take fixed also, fixed also, the LOD going to work. It means without the keyword also the LOD going to work. Okay, without the keyword also the LOD going to work. Okay, so this expression also computed the complete data source level. This one's drag fixed, drag it and drop it here. See here, it is computing at the level of the data source. Both the fixed one and the fixed one copy. Okay, it has given us the same output. So this expression is called as this expression is called as the table scoped LOD. This expression is called as the table scoped LOD. So the scope of the table, if the scope of the LOD is at the table level, So if the scope of the LOD is at the table level or at the data source level, then such a kind of LOD is called as the table scope. So at which level this LOD expression is computing? At the level of the visualization or at the level of the table. So we can able to compute at the required dimensionality level or even at the required, okay, or even at the required multiple dimensionalities level, or even we can able to compute the complete data source level also. And in fact, even in the dimensionality, just we have taken only one dimension, right? If you see here just we have taken only one dimension. So is it possible to take here multiple dimensionalities or not? Yes. The answer is yes. Even we can take multiple dimensionalities also. So how to take the multiple dimensionalities? If you want to take the multiple dimensionalities, you just keep comma and take the required dimension. So there is no limit for here the number of dimensionalities. So here we can take the required number of dimensionalities in the LOD expression. Okay. So I'm taking here country, or let me take container. Next I'm taking here country. Okay, now after taking the country, I'm taking this department. I'm taking a department. Okay, see here we can take n number of dimensions here. So all these are the basics of the LODs. If you want to work with LODs, we should know these basics. Okay. So any questions till now on this? Any questions on the LODs? On the basics of LODs? So one important note point is this keyword. Okay, this keyword is not mandatory and this dimensionality is also not mandatory while building the LODs. Always the LOD should be between the curly brackets. Okay, the curly brackets are mandatory. So directly if you take sum of sales, it is going to compute at the data source level. Okay, it is going to compute at the data source level. So here I don't have any dimensionality here and I don't have any keyword. So keyword and the dimensionality is not mandatory. For example, here I'm taking colon and some dimension country. Okay, if I take only country and sum of sales, now it is giving us errors. So if you take the dimension, then the keyword is mandatory. Okay, then the keyword is mandatory. So if the dimensionality is existing, then the keyword should be exist, or then the keyword should be part of the expression. If I'm not having the dimensionality, and is it possible for the keyword to exist or not? Yes, the keyword can exist. The keyword can exist without the dimensionality, but the dimensionality cannot exist without the keyword. Okay, so the existence of keyword, it will never demands the existence of dimension. But the existence of dimension, it always demands the existence of the keyword. So it is one important point. And the next important point is the second advantage of LODs is we can able to perform the cohort analysis. Okay, with the help of the LODs, we can able to perform the cohort analysis. So what is cohort analysis? Cohort means group, okay, subgroup. If you want to compare the required group of data, okay, or if you want to compare the multiple subgroups of the data, then such a kind of analysis is called as the cohort analysis. And also, we can able to perform with the help of LODs, we can able to perform binning on the aggregate measures. We can able to perform binning on the aggregate measures. So normally, what is a bin? Bin is a subset of the measure, right? So if you right click on any measure, and if you go to create, here we can able to create bins. If I click on create bin, now here we can able to create the bins, right? So we're creating the bins on the aggregate measure or on the non-aggregate measure. See, just observe carefully. Where I click on the sales, and if we go to create and if we click on bin, Here we are creating bins on which field? On sales. It means on the non-aggregated field. On the non-aggregated field here I am creating the bins. Okay. So if you want to create the bins on the aggregate measures, till Tableau 8 it is not possible. Okay, till Tableau 8 it is not possible. Whereas, okay, with the LODs, basically what the LODs contains, if you go to the LOD field, this field contains the aggregation output only, right? So now if I right click on this and if we go to create, okay, now here we can able to create bins. So here we are creating the bin on the fixed. What is fixed contains? This fixed contains the aggregate output. So now here we are creating the bins on which fields? On the aggregate measures. It is the other advantage of the LODs. It is the other advantage of the LODs. So finally, where the, okay, before going to the actual tasks, where the LODs will execute, where all the LODs will execute. So all the LODs, they're going to execute at the data source level. The another advantageous factor of the LODs is all the LODs are going to execute at the data source level, not at the Tableau level. And in fact, the LODs will execute as a part of the query. As the part of the query, the LOD is going to execute. Okay. So what is the advantage? The advantage is, so if you are executing at the Tableau level means, so we have to bring the complete data into the Tableau or the network. So if you're connecting to the large data sources and if you're performing the table calculations, if you're connecting to the large data sources and if you're performing the table calculation, okay, then if you want to bring the huge amounts of data means it will take a lot of time to get that data. So here we are not getting the complete data into the Tableau. So here we are not getting that. Here we are not. I mean, with the help of the LODs, here we are avoiding that. Bringing the huge amounts of data into the Tableau. So it obviously improves the performance. So LODs will improve the performance if you're connecting to the large data sources because we are avoiding the large. We're avoiding the getting of that huge amounts of data into the Tableau. And even the LODs are having some drawbacks. So as the LODs are executing at the data source level, if the data source is slow and if the query is having some complex conditions, if the queries are having some complex join conditions, so to execute those join conditions at the data source level, it will take some time. So LODs is having its own benefits and its own drawbacks. So the benefit is what? Here we are not getting any data into the Tableau because all the evaluations we are doing at the data source level. So while working with the large data sources, it would be a huge performance gain. And in sometimes LODs will degrade the performance if as it is executing as the part of the underlying query, if the query is having any complex conditions or any complex joins, or if the query is having a huge number of conditions, then the LODs will take some time to execute. So these are the difference between the LODs and the table calculation. So where the table calculation will execute means the table calculation will execute at the Tableau level. So using the LODs, we're avoiding that burden of getting the data into the Tableau. So these are the basic things. So these are the basic things while working with LODs. So let's do some tasks on the LODs. Okay, let's do some tasks on the LODs. So first I'm starting with the fixed. Okay, first I'm starting with the fixed. So I'm having one task is okay. The task is here for a given market I would like to show what is each country's percent of total global sales. For a given market here I would like to compute what is each country's percent of total global sales. So for this I'm using the global superstore. For this I'm using the global superstore. I'm connecting to the global superstore. So I'm going to the Tableau repository, inserting connectors. So I'm connecting to the orders. Okay, so I'm building a new sheet. So after connecting to the orders, so I'm building a map. I'm building a map using the country. I'm building a map using the country. So here, what I would like to show is, I would like to show country-wise, okay, the total percentage of the global sales. So I'm dragging the sales and I'm dropping into color. So how to get the percent of global sales for every country? Drag sales and drop it into label. Drag sales and drop it into label. So just simply right click on sales. So just add the table calculation and just take what percent of total. Here we are seeing, okay, the percentage contribution of each and every country. But the question is, for a given market, what is each country's percent of total global sales? Okay, what is each country's percent of total global sales? On the total global sales, what is each country's percentage for a given market? So how to get the given market? So we have to add the quick filter for the market. So just simply right click on the market. Just click on show filter. So for example, here we are seeing the percentage of US. What is the percentage of US to total sales? 18.17. So here I'm unselecting all and I'm selecting only US. If I select only US, here how much percentage your tableau is showing? 100%. So but what is the actual percentage of the US? The actual percentage of the US is 18.17%. As here I'm unable to see all the countries with perfection, just I'm performing the filtering. Okay. So the US percentage before selecting the US is 18.17. If I unselect all and if I select only US, here it is showing as 100%. Here it is showing as the 100%. Why it is showing as the 100%? Okay, the value is supposed to be only 18.17, right? So why it is showing 100%? So here we have to understand two things. So this view contains okay, two mechanisms. One is the filter mechanism, other is the table calibration mechanism. So where the filter will execute? Okay, all the filters will execute at the data source level. Okay, all the filters will execute at the data source level, and here we are having table calculation. Where the table calculation will execute? The table calculation is executing at the tableau level, right? So first here which is happening? Here we have two mechanisms. Number one filter, and next number two table calculation. So filter will execute as a part of the query because the filter, all filter conditions will be added to either where class or having class. So the filter will execute at the data source level. Filter will execute at the data source level, and the table calculation will execute at the tableau level. Okay, the table calculation will execute at the tableau level. Just now you are seeing. So first, which is happening here? First, the filtering is happening. So select US, resulting only US, and on the US data, it is finding, on the data of the US it is finding percent of total, and on the data of the US it is finding the percent of total. So that's why here I am seeing 100% here. But my requirement is, if I click on any market also, I have to show the same value. Okay, my value should display as same like the actual percentage. So the problem with the table calculations is, first the filter is happening, and then the table calculation is executing. Right? So then how to, yes.
Is applicable to everything you mean? That means we have filters, we should not use table calculation. Will it give wrong results all the time, or only this example?
No, every time the table calculation will work in a similar way, right? All the table calculation will execute at the tableau level only.
Yeah. So I'm saying that we should, whenever we are doing a task, we should not use filters and table calculations combinedly.
Actually, it depends on the the requirement. Okay, so every time they don't want to see the complete global sales. If they want to see only that region sales, for example, they want to see the percentage of two regions on the for example, they want to see the EU and US. If they want to compare these two markets, so now we have to take only the data from this two markets, right? And we have to show the percentage contribution.
Okay, it depends on case by case.
Yeah, it depends on the question or it depends on the requirement. If you want to keep the complete data, yes, then don't use the table calculations. Okay, so here first we should know here we should know the execution sequence, how internally they're going to execute. So let me show you the execution sequence. It is the execution sequence. Okay, if you have the filters, so how the filters will execute means the filters they're going to execute. The filters they're going to execute in this first. The execution order is first the extract filter, next the data source filter, next the context filter, next the dimension filter, next measure filter, and at the last the table calculation filter. So why extract filter first? Okay, why extract filter first? So at the time of connecting to the any data source, so if you define the extract connection, and if you want to get the extract some data, so how to get extract some data? We have to add the filter, right? We have to add the filter. So if you add filter at that level, it is okay. It is called as extract filter. It is having the highest priority and it will execute first. And next, number two, the data source filter. Okay, after connecting to the data source, next if you add any filter at the data source level, it is called as the data source filters. So why these two filters are executing first means these two filters will be executed at the data source level. Okay, these two filters will be executed at the data source level. Already we have seen on the filters. So what about the remaining? These four filters they are going to execute at the sheet level. The above two filters they are going to execute at the data source level. Okay, and the below four filters they are going to execute at the sheet level. If you want to define the context filter, we can able to define only at the sheet level. Let me show you. Just a minute. Okay. So if you go to Tableau, so at the data source level, we can able to add the filter. So if you add any filter at the data source level, so first what will happen? First the filtering will take place at the data source level and then it is going to give us the filtered data, right? Whereas if you add any filter at the sheet level, now Tableau going to perform filtering at the sheet only. So it means it is going to get the complete data into the Tableau and only on the sheet it is going to execute the condition. So first the data source filters will take place and then the sheet level filters will take place. Okay, and then the sheet level filters will take place. So these four filters they are going to execute at the sheet level. So on the sheet level, obviously the context filter will have the highest priority because the context filter will create what? Dependent and the independent filters. And after the context filter, next the dimension filters. So why the dimension filters first? So if you drag and drop any dimension, here are you seeing the grouped data or the ungrouped data? If I drag and drop any dimension, just here we are seeing what? Just here we are seeing the ungrouped data for the dimension. As the dimension being the discrete, for the dimension Tableau will never add any aggregation. For the dimension, Tableau will never add any aggregation. Whereas if you drag and drop any measure, for the measures Tableau will add the aggregations. So we have some basic idea on the SQL where all the dimension conditions will be executed means in the where class. In the SQL we have the different classes. Okay, the different classes select from, where, group by, having and order by. So what the select contains? What the select contains? Select, it just selects the data. Okay, select, it is going to select the data. Okay, select, it contains the required list of columns. What about from? From class, it contains the data sets. It contains the data source. From class, it contains the data source. So the select going to select the data, right? So from where the select statement going to select the data? Okay, select, it selects the required list of columns, or it contains the required list of columns. So from where it will select the required list of columns? From the data source. So where we have to specify the data source means in the from class. So after from class, the next class is where class. So what where class will do? Where class, it contains the conditions. It contains the conditions on the ungrouped data. So ungrouped data means the data which is not having any aggregation. Always the data will exist in two formats, guys. Always the data will exist in two formats. Number one, grouped format, and number two, ungrouped format. So what is grouped format? Grouped format means the aggregated format. Okay, grouped format means the aggregated format, and ungrouped format means, okay, the row level data. It contains the conditions on the ungrouped data or the row level data. What about group by? Group by, it performs the data grouping. Group by, it performs the data grouping. What about having? Having class, it contains the conditions. It contains the conditions on the grouped data. Having class, it contains the conditions on the grouped data. It means on the aggregated data. So if we define any conditions on the aggregated data, where Tableau will add all the conditions means in the having class. So finally, order by. Order by just orders the data. Order by just orders the data either in the ascending order or in the descending order. So internally, how the select statement will execute means the execution order is always the execution will start from the from class, because the from class contains what the required data source. So after from, okay, the execution will goes to the where class. So after from the class, okay, after from class, the class having the highest, the class having highest priority is the where class, because where class, it just contains the conditions on the ungrouped data. It directly performs the condition execution. What about having? Having class, it contains the conditions on the grouped data. So first of all, we have to perform the data grouping. So how to perform the data grouping? With the help of the group by class. Group by class will perform the data grouping. So it means the having class is independent of the group by class. Sorry, the having class is dependent of the group by class, whereas the where class is independent of the group by class. Okay, this where class is independent of the group by class. So the where class can exist without group by, whereas having cannot exist without group by. Okay, because having, it contains the conditions on the group data. So first we have to perform the data grouping. So after where, next class, okay, the next class will execute as group by, because it will perform the data grouping. After the data grouping, next the having will execute. After the having, next select and order by. It is the execution order. It is the execution order of the select classes. So first from, next where, next group by, next having, and next select and order by. So in interviews I'll ask, which class gives the good performance? Where or having? Always where class gives the good performance, because it directly performs the, okay, execution on the existing data or on the row level data. What about having? Having directly cannot operate on the existing data. For having, first we have to perform the data grouping. So to work with the having, okay, both the group by and the having class has to be executed. So as where being the independent, it can directly execute. So only just one time data processing. Here you have to process the data for two times, one for group by and other for having. That's why always where class gives a good performance. So that's why in Tableau I have discussed it. Okay, I have given you one note, that is, it it is always recommended to perform filtering on the dimensions, because if you take any conditions on the dimensions, all the dimension filters will execute, all the dimensional filters will execute in the where class, and all the measure filters will execute on the having class. So if you take any filters on the measures, it will degrade the performance. It will degrade the performance. So it is recommended to take all the filters on the dimensions only. So now, if you see the filter execution sequence, so first the extract, next the data source, next context, and next the dimension filter, next the measure, and at the bottom the table calculations. So with the evaluation of the LODs, where the LODs will execute means the fixed LOD, it is going to execute before the dimensional filters. Fixed LOD, it is going to execute before the dimension filter. In between the context and the dimension, the fixed LOD will execute. Why the fixed LOD is executing before the dimension filters? Because this fixed, it is going to create two types of fields, both the dimensions and measures. The output of the fixed field can be either dimension or measure. Fixed is going to create the two types of fields, either dimensions or measures, depending on the formula. What about include and exclude? Always include and exclude, they are going to create the field of type measure only. Always the include and exclude, they are going to create the field of type measure only. So where include and exclude will execute means the include and exclude, it is going to execute above the measure filters. Include and exclude, they're going to execute just above the measure filters. So based on this logic, now let's work on our task. So as here we're having one filter, market. What is market? The dimension, right? So market is the dimension filter, and we have the table calculation. In our task. So first the market filter is executing, and then the table calculation is executing. So if I take some expression using fixed, then where fixed will execute? The fixed will execute at the fixed it is going to execute before the dimension filters. So now here how to compute the expression? Using fixed? Here we have to compute the percent of total. What is percent of total? What is percent of total? Each and every value divided by the total value, right? So here we have the each and every value. How to get the total value? Using fixed, how to get the total value? Just create a candidate field to get total sales. Just take, always the LOD should start within the curly brackets. Just take fixed sum of sales. So to get the total sales, I am taking fixed sum of sales. It is also called as what? Table scoped LOD, because fixed is going to compute at the dimensionality of the LOD. Here I am not having any dimension. So it is going to take the sum of sales at the complete data source. So hit apply and hit OK. Hit apply and hit OK once, drag the total sales and drop it into the label. So if you drag the total sales and if you drop it into the label, if you select all the markets, your tableau is showing the total sales. The total sales is 12.6. If you uncheck all and you select any market also, your tableau is showing the same value. Why here? Because the fixed is executing before the dimension. So now here I am finding out the percentage of the total. How to find out the percentage of the total? So what is the percentage of the total formula? Each and every value divided by the total value, right? So I am getting a calculated percent of total. So I am taking sum of sales. Divided by total sales. Divided by total sales. Here it is giving us errors. Why it is giving us errors here? If you see the error, can I see the message? Cannot mix aggregate and the non-aggregate. So your sum of sales is aggregated. What about total sales? This total sales is the LOD field. Right? Already in the LOD we are having aggregation, but here Tableau here Tableau, it won't identify that aggregation. We have to pass the aggregation here. So again, I'm taking here sum. Again, here I'm taking sum, but the value it won't change. Okay. So just click on apply and click on OK. Once drag the percent of total, drag it and drop it into label. Here we got the percent of total. So here how to get the percentage? It is showing 0.1817. How to get the percentage? Just go to percent of total. Just go to the default properties, number format, select percentage and just hit OK. See how much percentage we are having for the US? 18.17. Just select all the markets. If you select all the markets, what's the value of US? 18.17. Just unselect all, select only US. If you select only US, it is showing the global percentage only. The percentage, okay, here the percentage is not changing because first here the LOD is calculating and then the filter is applying. Okay, and then the filter is applying. So now here what will happen if I convert this market to context? Let me convert this market to context. If we add to context, now here again the percentage has changed to 100%. Why? Because if you have the context filter and if you have the fixed LOD, so where the context filter will execute? The context filter will execute, okay, above the fixed LOD. So now here first the filtering is happening and then the fixed LOD is computing. So if I take the normal filter, now it is maintaining that the same percentage. So it is one of the advantageous features of the LODs. Okay, yes. So any questions on this task? Any questions on this task?
The last point, can you explain when you add context filter, why did it made it to 100%?
No, actually if you take the context filter, so first which one will execute, filter or LOD? Here you have the fixed LOD, right?
Yes, yeah.
If you have the context filter and if you have the fixed LOD, first which one will execute? First the context filter will execute. So it means what? In the context filter, if you select let's say US, it is going to give us the US data. After getting the US data, it is going to compute what the percentage. Same like the table calculation.
Yeah.
See, if I take context here, so it is converted to 100% because here I'm having only US, right? So if we select all, okay, if we select all, now it is going to work. Whereas if you unselect the market and if you select only US, now it is showing 100% because first the context filter is executing and then it is computing the fixed. Just to show you the filter execution sequence, I converted that to context. Okay. So again, I'm removing the context. Right click and click on remove from context. Okay. So any other questions on this? All right. So I'm moving to the next task. My next task is here I would like to show how many customers have made, okay, how many customers have made 1, 2, 3 and n orders. Okay, how many customers have made 1 order, 2 order and 3 orders. Okay, in the form of a histogram. I would like to show. So what does it mean is, for example, here I'm taking customer. Here I'm taking the customer and I'm taking the orders. I'm counting this to count distinct. So here we have some customers. If you see here, this customer is having how many orders? 7 orders. Okay, this customer is having 7 orders. So with 41 orders, we're having 1 customer, and with the 39 orders, we're having 2 customers. With the 38 orders, we're having 4 customers, and with the 37 orders, we're having 10 customers. So what I would like to do is instead of showing like this, here the requirement is to find out, okay, how many orders made by, or how many customers have made one order, two order, three orders. The requirement is to show how many customers have made one order, two order, three orders. So I would like to convert this view into like this. Okay, into like this. So with one order we're having 10 customers. With two orders we're having some 20 customers. With three orders we're having 30 customers. So in this way the requirement is to build one histogram. So if you take the view, we got the view like this. The requirement is to convert the view into this form. So here you have to show like, okay, with 38. Here you have to show 38 in this axis, and here you have to show here how many customers are having 38 orders? 4. Here you have to show the count 4. So then how to get the customers with the number of orders? So this type of analysis is called as the cohort analysis. So I'm finding customer wise number of orders. Okay, number of orders by customer. Number of orders by customer. How to get the number of orders by customer? Just I'm taking fixed. I'm taking fixed customer ID. I'm taking fixed customer ID. I'm taking count D of order ID. Count D of order ID, okay? So what fixed is going to do here? Fixed is going to compute at each and every customer ID level, and it is going to count what? Number of orders. It is going to count number of orders for every customer ID. Just click on apply and click on OK. So number of orders by customer, just drag it and drop it into the rows. Okay, just drag it and drop it into the rows. So it is giving us the number of orders. So just here what I'm doing is just I'm converting this to the dimension. So even the fixed fields we can convert that to the even fixed fields we can able to convert to the dimensions. Drag the number of orders and drop it into the rows. So here we have from 1 to 41 orders. We go to the previous sheet. So here what the maximum order count? 41. And what about the minimum? What about the minimum? The minimum is 1 and the maximum is 41. So go to the next sheet. Go to the next sheet. Just drag the customer ID and drop it into the columns. Drag the customer ID and just count all the customers. Just take count distinct. Just take count distinct. So now see here. Now here we got the required visualization. Just click on ABC. So with one order we're having 10 customers. Okay, with 2 we have 24, with 3 we have 62 customers, and with the 3 orders we have 110, with 5 we have 110. So with 41 we have 1 customer. Just compare once. With 41 we got 1, with 39 we got 2, 38 4. So 39 to 38 4, and 37 we got 11. With 37 here we got 11, and with 36 we got I think 12. So we got the correct output. So just here the logic is very simple. Just here I have taken the number of orders by customer and just I have converted that field to the dimension. So using fixed we can able to create the field of type either measure or dimension. Whereas always the include and exclude, they will create the field of type measures only. So here already we are having the include exclude fields, right? So if you drag the include field and if you drop it into the dimension, it won't take this here. I'm dragging include one. Include one is here under the measures only. So now if you drag the exclude, we cannot convert. Always include and exclude will create the field of type measures. Whereas we can convert the fixed field to dimension and dimension to measure. So that's why the fixed will execute before the dimension filters, and the include and exclude will execute before the measure filters. So let's move on to the next task. So any questions on this task is? Any questions? Alright, so I'm going to my next task. So we have one source called as the CO2. Okay, on the CO2 data source, the requirement is to create one bucket chat. Okay, the requirement is to create one bucket chat like this. Now on this bucket chat, what here we have to do is, so we have to bucket the states by number of CO2 emitting facilities they have. Okay, number of CO2 emitting facilities they have. Depending on the number of CO2 emitting facilities, here the requirement is to design a bucket chat. Okay, here the requirement is to design a bucket chat. So, and even if it is possible, here the requirement is to color each and every bin. The requirement is to color each and every bin depending on the total CO2 emitting facilities. Okay, depending on the total CO2 emission facilities within that bin by all the states. So how to build this view? So first of all, let me connect to this data source. I have to check it once. Just a minute, I have to check this data source. So from Tableau, I'll connect to this data source. Just go to Tableau, click on connect to the data. So it is of type extract. So from my how to connect to the extract files means, here we have an option called as other files. Click on other files. Just go to other files and select the Tableau data extract. Just go to the desktop and click on CO2 emissions. Click on open. So here we got the CO2 emissions. The question is to find out the number of CO2 emissions per state. Okay, how can we bucket our state by number of CO2 emitting facilities they have? So here the state is the dimension. The state is the dimension, and each and every facility will be identified by the facility type, I guess. Yeah, number of CO2 facilities means yes, the facility type. So first we have to find out the number of CO2 emitting facilities they have. So just create a calculated field, the name number of CO2 emitting facilities, number of CO2 facilities per state. So how to get per state? Take fixed state. So you have to count the number of facilities, right? So take count of facility ID. So the facility ID is okay. Just end this. So just click on apply. Click on OK. So here we got the number of CO2 facilities. Okay, just drag it and drop it here. Here, what we have to do is here we have to bucket all the states depending on the CO2 emitting facilities. Here we have to bucket all the states depending on the CO2 emitting facilities. So like this we have to create the bucket chat. So on the facilities here we are seeing something like 0 or 1500. So it is a bin. Okay, we have to create a bin. Just go to the number of CO2 facility units. So just now we have seen already this field contains what aggregation. Even on the aggregations, it is possible to create the bins. Just simply right click on the CO2 emitting facilities. Just go to create and click on bin. So just give the name as CO2 emitting facilities bin, and I'm giving the bin size as 50. I'm giving the bin size as 50. So the minimum is 2, the maximum is 1063. So just hit OK. Drag that number of CO2 emitting facilities bin, drag it and drop it into the rows. So here we are seeing from 0 to 1050. Next, after placing that, just take the state and drop it into rows. Just take the state and drop it into rows. Now right click on it Just count the number of states we're having. Okay, just count the number of states we're having in that. Now drag the state and drop it into label. Okay, drag the state and drop it into label. So now here we got the bucket chart. Now here we got the required bucket charts here. Here we got the required bucket chart. So just to show the number of CO2 facility emitting, just to show the number of CO2 emitting facilities, just drag the facility ID, drop it in the label, and show it as count distinct. Just go to presentation mode. Now here we are seeing the state wise number of CO2 facility units. So here what is 0 bin indicates from 0 to 49, and what is 50 bin indicates from 50 to 99. What is 100 bin? From 100 to 149. So these states are falling from 0 to 49 facilities bin. Now after building this chart, we have to color this chart. Okay, we have to color code this chart. So how to color this chart? By their total emitting facilities. So here I have to color only this bin. Okay, so how to color only this bin? Depending on the total reported emissions. We have one measure called as total reported emissions. Okay, so now we have to color this bin. Here we have to color this bin depending on the total reported emissions of this bin. So here we have the view at which level? Here we are having the visualization at which level? So which fields will add the level of detail? Okay, always the dimensions will add the level of detail, right? So on the columns we are having the bin dimension, bin being the dimension, and also the label will add the level of detail, right? So only the two shells they won't add the level of detail. One is the tooltip. Tooltip it will never add the level of detail, and the other is filters. Filters also it will never add the level of detail. So bin will add the LOD at the base, and also here the state is adding, the level of detail, okay, for this visualization. But here what we would like to compute is, here we would like to compute, or here we would like to color, each and every bin only, depending on the total reported emissions. So how to color only one bin? Okay, how to color only that bin by eliminating the state. So just simply take exclude. So I'm creating one calculated bin with total reported emissions. Total reported emissions per bin. So as we have to compute for every bin, here we have one more dimension called as state, right? Just exclude state. Exclude state and take the total sum of total reported emissions. So excluding state means in the view we're having only one thing, bin, it is going to compute for the bin. So just click on apply and click on OK. So drag the total reported emissions per bin, drag it and drop it into color. Okay, drag it and drop it into color. So now here which bin is showing in the darker color? Okay, these two bins are showing in the darker color. It means what? These two bins are having the highest reported emissions. Okay, their CO2 emissions are very high. The 100 bin and the 150 bin. Alright. So any questions on this case? Any questions on this task? Any questions on this task? Alright, so let me go to the next task. So next here, I want to perform one more cohort analysis. In this analysis, like what I would like to show is the yearly sales broken down by the first purchase date of the customers. So depending on the first purchase date of the customers or depending on the first purchase year, the requirement is to find out the yearly sales. Okay. So if I take, I'm using global superstore, I'm taking the order date, and I'm taking sales. So now here what Tableau is giving us, here Tableau going to give us the year-wise sales, right? So this year contains only 2011 customers, and this year contains what? 2011 plus 2012, and this year contains what? 2011, 2012, and 2013. So here the requirement is to find out what is the sales contribution of all the customers. What is the sales contribution of all the customers depending on their purchase date or depending on their first purchase date. Okay, depending on their first purchase date, here we need to find out the total sales contribution. So if you see this view below, so here we are seeing the total sales within each year as just now we have seen. So here what we want to see is, so how much amount of sales contributed by 2011 customers in the 2012 and similarly in 2013 and 2014. So here what we would like to do is we would like to break down this view. Okay, so we want to create a new field that we can place on the color shelf of the marks card that will break up the bars, okay, based on the first purchase year of the customers. Based on the first purchase year of the customers. Okay, so how to get the first purchase year of the customers? For example, a light blue bar groups all the customers whose first purchase was in the year 2011. This here in the light the blue here it is showing the bar, right? So it's a contribution of the 2011 customers, okay, in all the years, in 11, in 12, in 13, and in 14. So here the question is how to find out this. Okay, here how to find out this. So how to get the first purchase date for every customer. So we want to get the first purchase date for every customer. So every customer means what? Just take fixed customer ID. So how to get the first purchase date? Just I'm taking min of order date. Just I'm taking min of order date to compute the first purchase date. Okay, just click on apply and click on OK. So now after getting the first purchase date, just drag the first purchase date and drop it into color. So now here we are seeing the first purchase date wise sales. So once drag the sales and drop it into label. Okay, So now you see here, now in the year 2011, the 2011 customers they have contributed this much. In the year 2012, the 2011 customers have contributed this much, 2013 this much, and 2014 this much. So in 2012, how much percentage of how much amount of sales contributed by 2011 customers? So see here, okay, the newly added customers in the year 2012, the newly added customers are only the 2012 customers. They have contributed 128,000. And in the year 2013, the newly added customers have contributed 130,000. Whereas in the year 12, okay, the year of first purchase date, it means the 2012 customers they have contributed 162,795. So on this, just compute the percent of total. So how to compute percent of total? Just simply right click, go to quick table calculation, just percent of total. So it is giving us 17.87, 20.16. I want to compute for every year. So how to compute for every year? For every year, what is the sales percentage of the customers depending on the first purchase date? So already I have told, while working with the table calculations, if we get the wrong output, we have to look into two things. Number one, addressing option, and number two, the logic. So here, as here we have added the formula automatically, we have to look into the logic. Just simply right click on it. Once go to the edit table calculation. Okay, so it is percent of total. So once see the formula, it is taking this logic. So sum of sales divided by total of sales. So the logic is correct. Okay, the first one is correct. Next, what about the addressing? So let's look into the addressing. So it is computing across what? It is computing across the table, but we have to compute depending on the first purchase date. Right? So just select compute using first purchase date. So if we select compute using first purchase date, so in the 2011 customer, in the 2011, the 2011 customer is contributing 100%. And in the 2012, okay, the customers who performed their purchase in the 2011, they're contributing 95.19. In 13, 95.18. In 14, 95.02. So in this way, okay, we can able to perform the cohort analysis. This type of analysis is called as the cohort because we have taken 2011 as one group, 2012 as one group, 13 and 14 as the other groups, and we're computing the values. So this year in 2014, okay, in 2014, the 2014 customers are contributing. Okay, the 2014, the newly added customers are contributing just 0.31%, and 20 that are contributing 0.88%, and 2012 customers are contributing 3.79%. Okay, so it's all about the fixed tasks. It's all about the fixed tasks. Okay, so I hope it's clear, right? So these tasks definitely will confuse you. You have to practice this. Okay, you have to practice these tasks. Okay, so on all these tasks, if you have any questions, you could post your questions on all these 4 tasks, or in fact 5 tasks. See, in the next release of Tableau, the LODs plays a crucial role because till Tableau 8, if you want to perform the aggregations other than the view level, we have to do a lot of dirty work. Like you have to do a lot of calculations, and in that calculation, you have to take one more calculation. With the evaluation of the LODs, okay, we can do it very, we can do the aggregation of the required dimensions very easily. But the thing is, you should know how to write that logic. Okay, it comes with the practice. It comes with the practice, so you have to practice all these tasks. So let me move on to my next type of tasks. So here the question is, using an LOD expression, what is the average sales per city in each state? In each state, what is the average sales per city? Okay, so basically the current view is showing here. The current view is showing us average sales per state. Okay, average sales per state. Here, what we would like to do is we would like to add is one more lowest level, city. What is the average sales per state per city? So one state will have multiple cities, so we have to take the average values we have to find out the summation of all the cities divided by number of cities, and we have to get the average value, okay, per city in per state. So we have to show, okay, we have to show like this. So we can do that by adding the reference line. But on the map, I want the average value per city in each and every state. So suppose let's build the map. Just I'm taking state. Just click on the state geographic field. Okay, just drag the sales. So we have the map. We have the map. Okay, at the average sales per state. I'm dragging the sales and I'm dropping into label. So how to get the average sales? Right click on it. Just go to measure values, click on average. Now right click on it, go to measure, click on average. Right? So it is giving us average sales value per state, right? So here how to show the average sales value per city also. So just create an LOD. So average sales per city. So here what would be the logic here? Include. You have to include city also, include city. Okay, include city. After including city, after including city, then what would be here? What would be the aggregation here? After including city here, what would be the aggregation? First we have to compute. First we have to compute the sum of sales. Just here what I'm finding out here is, just I'm taking, okay, state wise, city wise total sales. Just on the whole, just take the average. On the whole, just take the average. Just here I'm computing the state wise, city wise total sales. After getting the total sales, just get the average of all the values. Just click on apply and click on OK. So once drag the average sales per city, just drag it and drop it into tooltip. So if you see here, okay, if you see the state, here the average sales per this state is, so let me go to tooltip, let me add something here, I'm adding average sales per state. So we click on OK. Now here for Arizona, the average sales per state is 158, but per city is 2714. Okay. So in this state of California, the state average is 229, whereas city average is 5650. So here you may get one doubt here. Why am I taking first the sum? Okay, if I directly take here the average, then here what it is going to give us here? For example, I'm taking state and I'm taking city here. Okay, and I'm taking sales. I'm taking total sales. So here what I would like to do is here I would like to compute, okay, state wise average values of all the cities. So here how to get the average values of all the cities? So here which sales that I'm showing here, sum of sales. It is giving us what? State wise, city wise sum of sales. Now on the sum of sales we have to find out average. So how to get the average here? How to get the average? Just here we have to take what? So directly we can able to write the logic in the line. It is called as ad hoc calculation. Here we can take window average. To take window average of sum of sales. Now Tableau going to compute the average value. Now Tableau going to compute the average value for all the states because it is computing in the table down. Just go to edit table calculation. Go to advanced. Place city into the addressing and state into the partitioning. Just click on apply. Now it is computing. Now it is computing for all the cities in every state. So first we have to get the total sales of every city. After getting the total sales of every city, then we have to compute what average. That's why here first I have taken here the summation and then I have taken the average. So if you see all the LOD tasks, even though in the part 3 we are taking the aggregation to drag any LOD field, again it is going to take what? One more aggregation. Okay, aggregation on the aggregation. So next, aggregation on the aggregation. So if you go to this task, here what Tableau is taking here, AGG. On the average sales per city, here Tableau is taking here AGG because here inside the LOD you are having one aggregation and on the output of the LOD here I have taken average here. So here already we have taken aggregation on the aggregation. So that's why Tableau is taking average. Even we can take the average here. Even we can drag the LOD field here and we can take the average here. So just go to Tableau. So here I'm taking the next task. So I'm having a highlight table I'm having a highlight table of sales. Okay, I'm having a highlight table of sales broken down by customer segment and year. Okay, broken down by customer segment and the year. So what I would like to do is I would like to color each of this customer segment. Here I would like to color each of this customer segment and year combinations based on the total sales value, based on the total sales value of the highest region. Okay, based on the total sales value of the highest region, here I would like to color. So every year and every customer segment has to be colored with the highest total sales value of the region. It means take the year and if you take the customer segment, I'm taking year and I'm taking customer segment and I'm taking region and I'm taking region. So we take the sales. If I take the sales here, which region is on the highest sales? Okay, international. So international is on the highest sales. So here the requirement is to color the customer segment wise, year wise highlight table. I'm taking customer segment here. I'm taking here the year. So customer segment wise, year wise, I'm showing here the total sales. And I'm building the highlight table. Here, if you click on the highlight table tab, you're going to color with that measure, right? But here, how I would like to color the visualization means depending on the highest total sales value in the region. So how to get the highest total sales value in every region? So just create a calculated field with the name highest total sales. So what is the logic? Fixed region sum of sales. I'm taking fixed region sum of sales. Okay, it is going to give us the region wise total sales. And on this I'm taking max. On this I'm taking max to compute the maximum value. So click on apply and click on OK. Now once drag is highest total region sales. Okay, highest total sales. Just drag it and drop it into. So now it is computing. Now it is computing. Sorry, not fixed. Okay. As if you have to include, not fix it. For every, okay, here you have to compute. The question is, you want to color each of the customer segment and year combination. So you have to include the region along with the customer segment and the year, not fix. You have to take include. Because for every year and the customer segment combination, you have to show the maximum value. Just click on apply and click on OK. So now here we are coloring based on highest total sales in the region. So if you see here, it is showing highest total sales in the consumer customer segment in the year 2010. Okay, in the consumer segment in the year 2010, what the highest total sales? The highest total sales is 840. Once check the output. In the consumer 2010, what the highest sales? 840. And in the year 2010 corporate, what the highest sales? 1.64 million. So once go to the sheet. So in the corporate, say what the highest total sales? 1.647 million. So here we're coloring this particular highlight table, okay, with the highest total sales value in that region. So these type of requirements we are frequently facing in the real time use, okay. So LOD is a must and should. If you want to be in Tableau, you should learn LODs. Next task. Next, the question is, how do we compare our states? How do we compare our states based on their highest CO2 emitting counting? Okay, based on the highest CO2 emitting county. Here the requirement is to compare all the states. So how to compare all the states depending on the highest CO2 emitting county. Okay. So how to get the highest CO2 emitting county. So here like we have the map. Here we have the map at the city level. So at the county level, you have to compare all the counties depending on the highest CO2 emitting county. Let me build a map for county. Just go to the mapping items. I think in the global superstructure I'm in the county. Sorry, not global superstructure, in CO2. In CO2 we're having the county. Just click on the county. So here you have to compare all the counties depending on the total CO2 emissions. Okay, depending on the or based on the highest CO2 emitting county. So how to get the highest CO2 emitting county? How to get the highest CO2 emitting county? So just create a calculated field. So highest emitting county. Okay, highest emitting county. Just use include. Use include. So you have to include the county. You have to include the county. So we have to find out what? We have to find out the total report emissions of all the counties. We have to find out the total reported emissions of all the counties. Now on the total reported emissions, we have to find out the highest. How to get the highest? Take max of. Take max of. Just click on apply and click on OK. So drag the highest emitting county, drag it and drop it into color. Okay, drag it and drop it into color. So it is showing us the highest CO2 emitting county. Okay. Just we're comparing with the highest CO2 emitting county. All the counties we're comparing with the highest CO2 emitting county. So how to compare with the highest CO2 emitting zip code or postal code? Just create a calculated field, zip code. So take include. Now we have to include the postal code also, include zip code. Just get the total reported emissions. Now only just find out the maximum one. How to get the maximum? Just take max of. So just click on apply and click on OK. So once that zip code, just drag it and drop it into color. So even we can able to perform the analysis at the level of the zip code also. Okay, at the level of the zip code also. So we see in the state, this zip code is having the highest CO2 emitting facilities. Okay, and if we take this state and the state, okay, the zip code having the highest CO2 emitting facilities are this much. Okay. So depending on the question, we can easily, we can easily make it out whether we have to use either fixed or include or exclude. Let me jump to my next question. Okay, this question is very important. So nowadays we're getting these kind of requirements in the real time. So the requirement is what percentage of the products, okay, what percentage of the products within each state exceeded the target profit. Okay, within each state, what percentage of the profit, okay, what percentage of the products they have exceeded the target profit, how much they have reached the targets. So how to find out this? Okay, how to find out this? So we have to show the output line. So in this state, the total sales is this much. So and in this state, total 44% of the products they have exceeded the targets. So any ideas on this guys? So how to do this? How to do this task? Any ideas? So any ideas on this, like how to achieve this task? So for this we have to make use of the copy chain. For this we have to make use of the copy chain data source. I am connecting to the data source. I am using MS Access. Just click on browse, go to documents, tab repository, data sources. I'm taking RQ. I'm connecting to copy chain. Just hit open. Hit OK. Okay, here I'm connecting to the copy chain data source. Option is not there. Okay. Just go to edit. Okay, here I have certain tables. Just click on the copy chain query and go to the sheet level. So in the sheet here we are seeing the different things. So I'm taking the state, and I'm taking the product, and I'm taking the profit, I'm taking the profit, and I'm taking the budget profit. So budget profit is the target profit. So here it is the actual and it is a target. So if you see here how many states has reached the target. So this state has reached the target, right? Next, this state has reached the this product has reached the target, not state, and this product has reached the target, and this product has reached the target. This product has reached the target. Okay, this product has reached the target. This one, this one, this one, and this one. So out of 12, 8 has reached the targets. Okay, out of 12, 8 has reached the targets. So what about the percentage of the products? 8 by 12 into 100. Okay, 8 by 12 into 100. So it means close to 67% of the products in the California state has reached the targets. So how to do it in Tableau? By not taking, without taking the products. Let's see here. Without taking the products, just by taking only the state, here I would like to show how much percentage of products in every state have reached the target like this. I would like to show state-wise sales and how much percentage of the products have reached the target. So I'm taking here, so just to perform the evaluation, I'm creating a new sheet. I'm taking state first. Okay, I'm taking state first. So here I'm taking one simple calculation with the name KPI. With the name KPI, I'm taking sum of profit minus sum of budget profit minus sum of budget profit. Sum of profit minus sum of budget profit. Just I'm finding the difference. Click on apply. Click on apply. So here, just to the KPI, here I'm adding one more condition. To the KPI, here I'm adding one more condition. That is, here is a difference. Profit minus budget profit difference is greater than 0 or not. So here Tableau going to create a boolean field. So when this profit minus budget profit difference is, the difference is more than 0. If the profit is more than the budget profit, it means If the actual value is more than the targeted value, if the actual value is more than the targeted value, then then this profit is more than the budget profit. If it is less than, then it is less than 0. So if it is more than 0, here tableau going to use as true, else tableau going to use as false. Hit apply and hit OK. So once drag the product and drop it into text or drop it into rows. Drag KPI and drop it into text. Drag KPI and drop it into text. Here for this product is showing false, and for this product is taking for this product is taking true. Here true and here true. So here true indicates what? Their value is more than the targeted value. So one important certification question is how to convert the boolean values like true or false to zeros and ones. How to convert this true or false values to zeros and ones. So how to convert means one simple logic is just take here int of. Just take here int of. If you take here int of, Tableau going to convert that output to integers. Just click on apply and click on OK. So here how Tableau is showing the values. The Tableau is showing the values in terms of zeros and ones. Here Tableau is showing the values in terms of zeros and the ones. Now just count only the ones. Now just count only the ones. So how to count only the ones? Here how to count only the ones. On this total product, just count only the ones. So how to count only the ones here? Here how to count only the ones. Any ideas guys? So how to count only the ones here? Here what this one indicates? One indicates here the one indicates what? One indicates the product whose profit is more than the targeted profit, right? So here just I would like to count all the ones to know how many products are more than my target. How many products are more than my target? So here we got ones and zeros. So just simply use one logic. Just simply use one calculation. Use one calculation to find out number of products per state. Number of products per state. I'm taking include, because as I want only state, I'm taking include products. Include product. I'm taking count of KPI. I'm taking count of KPI. So it is giving us here the error. One check the error. So see here message augment to count already an aggregation cannot be further aggregated. So just remove the count here. Just take only the KPI. Now here Tableau is giving one more error here. So what are the messages? Level of detail expressions are not supported by MS Access data source. So now we have seen the first limitation of LODs. So by default LODs are not supported. By default LODs are not supported on all the data sources. LODs are currently supported on only few of the data sources. Then how to implement? Even though the data source is not supporting, just take the extract of the data source. Just take the extract on it. Just take the extract on it. Take the extract, then the LODs will support. Click on extract data. Just click on send. So now it is converting me to the extract. Next, just create the calculated field. Just create the calculated field. So just take that logic again, just go to the measures. So I think again we have to create that. So use include or number of products per state. Just take here include state. Just take KPI. Okay. So now the calculation is on. Just click on apply and click on OK. Drag the number of products per state. Drag it and drop into the text. So I want this to continuous. Just remove the product. Just remove the product. Just taking. Let's simply do one thing instead of taking like this. Just on the KPI. Just add the LOD. So let me take the calculation here. So I'm taking directly here. I'm taking here include product. I'm taking here. I'm taking the LOD. I'm taking it directly one expression. We can take directly the int. I'm taking here one expression. If it is greater than 0, then even with, just to show you the different ways of writing LOD, I'm taking this logical evaluation. Okay. If it is greater than 0, then I'm taking 1 else 0. Just end this. So even we can take the logical evaluations also like this. Even we can take the logical evaluations also like this. So here I'm ending this expected then. So if the sum of profit is greater than 0, so I'm ending the bracket here. I'm taking one more extra bracket. It's not here. Greater than 0, then 1 else 0. And it is taking O here. Here the issue is just here I'm taking O. Okay, instead of 0 I'm taking O here. I'm taking 0 here. So just click on apply and click on OK. So once drag the KPI and drop into text. So now it is showing here the number of products in that state. So in this product, just now you have seen it. California is having 8, right? So here we got the number of products. I am giving the name as products exceeded target. Okay, products exceeded target. Just click on apply and click on OK. So now just I'm taking the sales. And here how to get the percentage. So just create a calculated field to get the percentage of products per state. Take the products greater than target. Products greater than target divided by total products. Found D of products. The count D of products. It is giving us the error. So cannot mix aggregate and the non-aggregate. So okay, by default for the LODs, it won't take an aggregation or take aggregation. I'm taking sum of products greater than the target divided by counting just to get the count. Click on apply, just drag it and drop it into the columns. Just click on LC. So here how to get the percentage, just go to the default properties and the format, percentage, and just set up. So now drag it and drop it into product. So in this case the total sale is 96,892 and total 66.67% of the products have reached the target. In this case 54.55% of the products have reached the target. Okay, so here you are seeing the percentage of the products have reached the target. It is one of the most important tasks. So any questions on this task? Any questions on this task? Just we have to find out how many products have reached the target and we have to divide that with the total number of products. Okay, yes, any questions? Alright, so I'm going to the next type of tasks. So I'm going to the next type, exclude. I'm taking. Okay, so here I'm having a map. I'm having a map at the city level. In the tooltip, I would like to display the total sales value for the state, okay, where that city resides in. So what I would like to show is I would like to show the map at the city level, and even in that map at the city level, I would like to show the total sales where that city is existing. So how to build this? Okay, how to build this? First, let me show you the city-wide sales. Just go to Tableau, create a new sheet. Just click on city. Okay, now drag the sales and drop it into size. Okay, drag the sales and drop it into color. Here we got the city-wise. Okay, here we got city-wise sales. In the tooltip it is showing the sales. So we'll say just for a tooltip, name it as city sales. Name it as city sales, just hit off. So now in the tooltip here tab is showing us city sales, right? So here what I would like to show here is, here I would like to show in the below to the city sales, I would like to show the state sales also. So how to show this, here how to show the state sales. So how to show the state sales means, just create a calculated field. So here we are having the view at which level? Here the detail also will add the tooltip, right? So if you click on any geographic field, what Tableau will do means Tableau will add that dimension to the detail shelf. Okay, Tableau will add that dimension to the detail shelf. Okay, so now here as my view is at the country plus state plus city level, as here I want only at the city level, as here I want only at the state level, we can exclude city. So how to exclude city? Just create a calculated field with the name state sales. So just exclude city, and we have to get sum of sales. Okay, here we have to get sum of sales. Just click on apply and click on OK. Now drag that state sales and drop it into tooltip. So it is not showing the tooltip directly. We have to add it. Just go to tooltip. So here take that name state sales. Just go to insert and here take the state sales. Just hit OK. Now here So the city name is Mr. Falls, the state is Texas, and the city sales is 1690, the state sales is 543089. And if you want to get the country sales, just create one more calculated field with the name country sales. So just take here exclude. We have to exclude both the fields, city and state. So we can take here both the dimensions, city. Just remove the edit here. Just take city, and also you can exclude what? State. So just take the state here and take sum of sales. Okay. So it is giving us one error. One check that. See here, the message is all fields in the LOD expression must come from the same data source. I have taken this city from the global superstore. Okay, whereas the state is used sample superstore. So I'm taking a city. Okay, in sample superstore. So here I'm excluding the city and the state. Just click on apply and click on OK. So drag the country sales and drop it into tooltip. So if you observe carefully here, if you for all the exclude fields, Tableau will take the aggregation as ATTR. If you observe or not, for all the exclude fields, Tableau will take the aggregation as ATTR. For the include and fixed, Tableau will take the aggregation as normal, like sum or average. But for exclude, Tableau is taking the aggregation as ATTR. Why ATTR? There is a reason for this. I'll explain the reason. So once go to the tooltip, here add the country sales also. Add country sales. Just go to insert, just take country sales. Hit OK. Now we see here, now you are seeing country sales. So country is US, you're seeing the US sales. You go to India, the country is India, and you're seeing the India sales. Okay. So see here. So in this way, we can able to add the required values in the form of a map. Let me move to the next question. So now I'm having a visualization which contains the category wise, month wise sales. So here what I would like to do is how can we color the bars based on the overall sales value for each month. Okay, based on the overall sales value for each month by ignoring the category. It means just here I would like to color based on the month values by ignoring the category. So we go to Tableau. If you take the category, based on category, let me take the department. If you take the department, and if you take the month, and if you take the month, okay, just drag the sales and drop it into the rows. Bring this into my columns. Here I got the bar chart. Now here what I would like to do is if I drag any value, if I drag any sales and if I drop it into color, the Tableau going to color the visualization based on the values of both the month and the department, because here my visualization is at the level of month plus department. So Tableau going to color the visualization at the level of both the month and the department. So how to color only at the level of month by ignoring the department. So just simply use this create a calculator with the name month sales. Just exclude the department. Exclude the department and take sum of sales. Just exclude the department and take sum of sales. Click on apply and click on OK. Okay, so now once drag the month sales, drag it and drop it into color. Now we are coloring based on only the month sales. So here which one got the highest sales? November, because November is showing in the darker color. So the November got the highest sales. Okay, yes, here. Next question. Next question is most important. So I am having a view on the CO2 data source which contains the state-wise, facility-wise total reported emissions in the form of a highlight table. So here how I would like to color is, how can we change the coloring scheme of our highlight table to be based off either row or column grand totals. Okay, how to color the visualization depending on the row or the column grand totals. So by default, if you place the value, it is going to color on both the values. So how to color, either based on the row grand totals, okay, or based on the column grand totals. The view should be like this. Okay, the view should be like this, either based on the row grand totals or it should be based on the column grand totals. The most important task, okay, the most important task. Just go to Tableau. Just go to the CO2 data source. Drag the facility type into rows. Nothing. Not the facility. Yeah, drag the state. Drag the state into rows and drag the facility type into columns. Just drag the facility type into columns. Some starting the dates. Okay. Now take the total reported emissions. I'm dropping into text and I'm dropping into color. Just click on highlight table. Now here I would like to color. Now here I would like to color these values depending on the row grand totals and depending on the column grand totals. So how to color the view depending on the row and depending on the column grand totals. So now in the rows here what I'm having, in the rows I'm having the state. So here we have to take only the values from state by ignoring the columns. So how to ignore the column? So just create a calculator field to get the row grand totals. To get the row total. So in the row we are having the state. Just exclude facility type. So sum of reported emissions. Sum of total reported emissions. Okay. So now it is going to take what? In the row as you're having the state, it is going to take state. Just click on apply and click on OK. Once drag the row total and drop it into columns. Once drag the row total and drop it into columns. So now see here. Now here which state is having the highest CO2 emissions? This state, it is showing in the darker color. Okay, the Texas. The Texas is having the highest CO2 emissions. So how to add the row total? Click on analysis. Totals or row grand totals. Okay, row grand totals here. This value would be the highest one, the row grand total among all the values. Next, how to get the column grand totals. In the column here what are having the facility type, not to exclude the state. So just create a calculator field with the name. Column total. Column means facility type. So just take here. Exclude state. Sum of total reported emissions. So just click on apply and click on OK. So drag the column and drop it into color. So now it is counting the direct emissions in the darker color. It means this direct emissions is having the the highest contribution. highest contribution on the total reported emissions. So here, at a time we cannot color using both the fields, right? So what I would like to do is here I would like to add one parameter with the name color. I'm taking the type as string and the values I'm taking 2. One is row and the other is column. If I click on row, the requirement is to color with the row values. If I click on column, the requirement is to color with the column values. Okay, if I click on row, the requirement is to color with the row. If I click on column, the requirement is to color with the column. So how to achieve this? Just create a calculated field with the name coloring, dynamic coloring. So I'm taking if color equal to color parameter equal to row. Then we have to show row total. Else we are having only one condition, we can take column. Just end this. Just click on apply and click on OK. Now drag the coloring field and drop it into color. Okay, now we're coloring with the column. In the column here what I'm having, facility type. Now just select the row. Now just coloring with the row. In the row here what I'm having, state. So in this way we can able to add the dynamism. Okay, so I hope it's clear. So any questions guys till now? Any questions on exclude tasks? Any questions on exclude tasks? So I would like to give you one assignment task. Okay, so the assignment task is I am having one visualization like this. So I would like to find out the difference between the selected subcategory and the other subcategories in the sales. Here I am having one parameter. Okay, if I click on any category, I have to show the difference between this selected category and the remaining categories. Okay, the selected category and the remaining categories. And I want the output like this. Okay, I want the output like this. It's an assignment task. So I'll take this task in the evening. So just I would like to take a break for 20 minutes now. So after the break, like, are you available guys after 20 minutes? So I would like to know.